Hi, Ahava. Hi. Um, Today we're doing something slightly different because I wanted to introduce algebraic proofs to you in a slightly different way. So I am looking in your book literally at page 113 down here. Isn't that cool? So I am looking in your book and I'm doing this with my phone, so be patient with me. It's going to move and stuff. Probably going to make you sick or dizzy or something, but it happens. They want you to name the property of the real number illustrated by each statement. So for this one, it starts out as 5 plus 9 equals 9 plus 5. So from the left side to the right side, what changed was the order of stuff. That's why it's the commutative property, incidentally, of addition, because there's a plus there. Down here, what moved from this side to that side is the parentheses. It went from being around the 7 plus x to being around the 3 plus 7. So since the parentheses moved, that's the associative property of addition, because we're dealing with addition. Over here, looking on this side, up here you have the 6 on the outside and then the 2/3 plus 4 on the inside. And they distributed that 6 and gave 1 to each of those numbers. That's a distributive property. It doesn't have a of multiplication or of addition because it's both, so we don't say that for them. For number 4, it says 8 times 1 equals 8. What it started out as is what it ended up as. That's the identity property of multiplication because it's times 1. So, when you look down here, they broke down commutative property of addition and multiplication, associative property of addition and multiplication, inverse property of addition and multiplication, identity property of addition and multiplication. Then they have the distributive property, the property for multiplication of 0, property for -1 with multiplication, definition of subtraction, definition of division. Turn the page. Yes, there is more. Aren't you glad I'm not making you write all these down? Because I could. Just saying. The reflexive property, which says what it starts out as is what it ends up as. In other words, it equals itself. Symmetric property, if A equals B, then B equals A. Transitive property, A equals B and B equals C, then A equals C. The substitution property, which you use quite a bit, but we don't generally call it that. We could say simplifying, not necessarily substituting. And then down, okay, not down. Just kidding. So, when we look at the class exercises up here, let me see if I can make it a little bit better. I'm trying to steady my hand. It's not exactly working out. But anyway, when we look at the class exercises, they have a proof written here. And I wanted to go into some detail on these proofs because you're going to do them a lot when we get to geometry. And these are the only proofs that you're really going to get in algebra, so it's your first introduction to proofs. Anytime you have a proof, they're going to ask you to prove, and they have to use that word. They have to say prove. Prove for all real numbers a and b that a plus b plus negative b is equal to a. So they throw that up there, and then they want you to prove that. So you always start with what's given. That's why they wrote that there. And then your last line should be what it is that they want you to have. And in between, all you're doing is reducing stuff down. So I'm going to go into more detail with this on the board, but I want you to understand some things about proofs. Number one, it's always going to have a statement side, and it always has a reason side. For us, those reasons are properties. All those properties we just looked at, they're all considered reasons that we could use. They're like tools in our toolbox for proofs. And the same thing down here for problem number 2. They kind of told you the stuff that they wanted you to prove, and then they ask you how we're going to prove that. So we're going to look at this classroom exercise up here, and then we're going to talk a little bit about problem number 2, I think. I think that's what we're going to do. So anyway, I will see you in just a second. Okay, bye.